are attempting to understand for ourselves what does connected health mean. So we've made this definition, and we'll noodle on it a little bit more, but this is sort of something that we think is reasonable. It involves the concept, you can read it for yourself, of continuous sensing on the one hand, some sort of a rules engine that sits in the background and says time to do something about something that we've noticed. So there's enough data coming in, and it's beyond the human's ability to parse it all. Some ability to notify the appropriate individual, and that might be a provider, it might be a patient, it might be a family member. And then, most importantly, measure, evaluate, and improve outcomes. So that's the philosophy, the umbrella under which we're working. The two areas that we're thinking about here are important are e-health, which is more the telehealth side of the house. And again, this has to do with extending the reach of our providers beyond the traditional boundaries of the healthcare encounter. And this is growing very rapidly with a projected market of about $27 billion in the next couple of years. So big space, a lot of buzz in the periodicals that I get, on the web pages, in the news. You're well aware of this, that various flavors of telehealth are important, some of which are game changers, some of which, like this, are arguably less important, although I did have the opportunity. This is telesurgery, and people have actually done operations across the ocean. A cholecystectomy was done actually a number of years ago. This is the underwater facility that NASA uses to demo their capabilities on, and it's called NEMO. This is off Key West, and they've done operations from Toronto. This is a Toronto surgeon who's operated on sham animals in this underwater facility. This is something that the NASA organization has thought about. It becomes less relevant with distant travel because the transit time for an action and reaction is so long as the spaceship travels further away that it becomes unrealistic. I did want to show you, this is from a colleague in the American Telemedical Association, this next flick that is the military's vision of connected health. It's sort of scary and interesting, but worth seeing. This is from an advanced projects group in the Army. A colleague in that group sent this to me.
Man down, man down. Medevac, medevac.
The military believes this is all feasible in a 10-year time frame. It's obviously a different vision of what connected health is from what we typically think about, but it's worth stretching the boundaries of the conversation a little bit. They're pretty wild. The other area that we're going to talk much more about today is mHealth, which is mobile health. And again, this is a lot of our speakers will cover this. There are currently over 100,000 mHealth apps out there for patients, for providers. We're seeing a lot of activity in that space. People have done a lot in the way of hacking the capabilities of phones, and the phone manufacturers are now developing phones that have medical chips built into them. In terms of where we are, this was yesteryear, where this was all relatively experimental. We're now in sort of a maturation phase, and I think we'll see an integration phase where this becomes part of doing business in the next couple of years. There was a news article in the last couple of days that said that doctors are prescribing apps now for their patients. This was in the Philadelphia Inquirer this weekend. This covers devices that measure health as well as sickness, and this is some vision of what the future might look like. May not be the one that you like, but this is the way people argue that we might be going. So I'm going to finish up. I want to just talk one more minute about the direction in which I think we should be thinking about things. There's a Nobel Prize winning physicist named Richard Feynman, who truly was the most interesting man in the world in his era. And he gave a cocktail party talk in 1959 entitled "There's Plenty of Room at the Bottom" to a bunch of grad students. And he basically described the concept of nanomedicine, of nanotechnology really, in a short half-an-hour discussion. That discussion actually led to the development of this movie, which is Fantastic Voyage. I'm sure many of you remember this, about making something very small that might do something health-related in the bloodstream. We now have a growing population of very small things. These are RFID tag pills. You take them, the gastric acid turns on a battery. The battery communicates with this sensor pad, which then communicates in turn to your phone and tells something about patient medication adherence. Roy was kind enough to send me this particular reference, which is about an implant that could be used as a subcutaneous laboratory and track various indicators of interest in the bloodstream, including, for example, troponin, which is an early marker of an MI. This is a medication delivery device. Phase 1 is basically intended to be a constant delivery passive device. When we give pills, there's a peak and a trough. If you give a medication that's subcutaneous, it can be steady state. And phase 2, they intend to have something that senses and delivers as needed. So essentially an artificial organ. You can imagine something that senses glucose and delivers insulin appropriately. It's essentially an artificial nanoscale pancreas. This is the direction in which things are going in the very near term.